But if we could wind the clock back more than 120 million years, to the early Cretaceous, this peaceful-looking corner of Europe would be almost unrecognizable. Southern England, and especially the area we now call the Isle of Wight, was once a hot, humid floodplain. Great rivers snaked across the land, forests crowded the banks, and enormous storms regularly flooded the lowlands. And stalking through this ancient world was a predator so formidable that even Spinosaurs may have had reason to fear it. This is the story of Neovenator, the English dinosaur that ruled the Wessex Formation. Segment 1, a dangerous England picture the southern coast of England, not as chalk cliffs and quiet beaches, but as a vast, steaming flatland. The Wessex Formation, exposed today on the Isle of Wight, records this environment in extraordinary detail. Over 120 million years ago, this region lay on a broad coastal floodplain. The climate was warm, Mediterranean-like, but wetter. Rivers meandered across the landscape, frequently overflowing their banks and carving new channels. Between them were forests, swamps, and shallow ponds. And in this world lived a cast of predators that wouldn't be out of place in a monster movie. Early tyrannosauroids, small but fast and deadly. Long-snout Spinosaurs, adapted for hunting in water, and towering above most of them, a large allosauride theropod. Neovenator, roughly 7 meters or 23 feet from snout to tail. Neovenator wasn't just another meat-eater. It was one of the apex predators of this ecosystem, a top hunter in a landscape already full of killers. Its discovery would completely change how paleontologists viewed the dinosaurs of Britain. Segment 2, Discovery of the New Hunter. The story of Neovenator starts not in the age of dinosaurs, but in the summer of 1978 on the Isle of Wight. Holidaymakers walking along the base of the cliffs noticed dark fragments of bone that had weathered out of the rock and washed onto the foreshore. Curious, they picked them up. Around the same time, a geology student visiting the area collected more pieces. These fragments eventually made their way to local museums and then on to the Natural History Museum in London. There, paleontologists realized that the bones represented at least 2 dinosaurs, one herbivore and one large carnivore that didn't match anything known from Britain. Throughout the 1980s, more bones continued to erode out of the cliffs. Different collectors, visiting at different times, all found pieces of the same skeleton and of other individuals. Slowly, researchers began to piece the animal together: vertebrae, limb bones, skull elements. What emerged was one of the most complete large theropod skeletons ever discovered in England in 1990. A preliminary scientific report announced this mysterious predator to the scientific community. But it wasn't until 1996 that the dinosaur finally received its formal name, Neovenator celerii, the New Hunter, named partly in honor of the Celero family, on whose land the fossils were found. Today, Neovenator remains one of the Isle of Wight's most complete and important large theropods. It gave paleontologists a new window into early Cretaceous Britain and revealed that the island once hosted a powerful allosauroid predator, something no one had expected from this part of the world. Segment 3, a floodplain. Turned to stone to understand Neovenator. We also have to understand the rocks it comes from. Neovenator's bones were preserved in the Wessex Formation, a subdivision of the larger Wealden Group. These rocks span roughly 15 to 20 million years of Earth's history and record major changes to the local environment, the base of the sequence. The rocks preserve river and lake ecosystems spread across a broad floodplain. Over time, as global and regional conditions changed, this environment shifted. The rivers gave way to lagoons and wetlands with increasing marine influence as sea level rose. Eventually, much of the floodplain was flooded and transformed. Neovenator itself comes from a very particular kind of deposit within these rocks: plant debris beds. These are layers of blue or dark clay filled with burnt wood, plant material, and the remains of animals that were swept into ponds or oxbow lakes during floods. The water at the bottoms of these ponds was often anoxic, almost no oxygen. That meant there were few bacteria and scavengers to break down the carcasses. When animals like Neovenator died and washed into these stagnant pools, they were buried quickly in mud and plant material. Over millions of years, those muds hardened into rock, preserving skeletons in remarkable detail. It's thanks to these plant debris beds that we have such spectacular fossils from the Isle of Wight today. Neovenator, along with many other dinosaurs from the Wessex Formation, owe their survival in the fossil record to these ancient floodplain traps. Segment 4, a family tree in flux. Neovenator's bones told scientists a lot about its body. But figuring out where it belongs on the dinosaur family tree has been a scientific saga of its own. When Neovenator was first carefully studied, paleontologists noticed that many aspects of its anatomy, especially in the skull and skeleton, resembled Allosaurus, the famous Jurassic predator from North America. For a time, Neovenator was considered a close relative, possibly even a sister taxon to Allosaurus. Both were part of the broader group Allosauroidea, large-bodied, lightly built predators that dominated the Jurassic and early Cretaceous. Later, more detailed analyses shifted Neovenator slightly. It was reclassified as an early diverging member of Carcharodontosauridae, the shark-toothed reptiles, a group that includes giants like Carcharodontosaurus from Africa. These dinosaurs are named for their teeth, which resemble the serrated blades of a shark. Then, in the early 2010s, things changed again. A new proposal placed Neovenator at the base of its own family, Neovenatoridae, and suggested that this family included the enigmatic megaraptors, large, big-armed predators with huge claws and uncertain relationships. Under that scheme, Neovenatoridae would have survived almost to the very end of the Cretaceous, thanks to the persistence of megaraptors. But as more fossils and better analyses appeared, especially for megaraptors, the picture shifted once more. Many recent studies suggest that megaraptors are actually tyrannosauroids, more closely related to T. rex than to allosauroids. With megaraptors gone from the allosauroid family tree, Neovenator has again moved positions. The current view is that Neovenator is still an allosauroid, likely representing a very small, possibly even single-species family of its own. What hasn't changed is its ecological role. Whatever its exact position on the tree, Neovenator was part of the allosauroid radiation that, for much of the Jurassic and early Cretaceous, produced some of the planet's top predators, long before Tyrannosaurs took over at the very end of the period. Segment 5, life on the Wessex floodplain. Neovenator didn't live alone. Its world was crowded with other dinosaurs and animals, each occupying its own niche in the ecosystem. On land, huge iguanodontian herbivores roamed the floodplains, animals like the big iguanodonts and a medium-sized form later named Bristonius. Long-necked sauropods grazed the higher vegetation. Smaller ornithopods darted through undergrowth. In the rivers and ponds lived crocodiles, fish, and early mammals. Insects were abundant, and fragmentary fossils give hints of their diversity at the top of the food web. Allosauroids like Neovenator were among the largest predators, but they shared the landscape with other carnivores, including early tyrannosauroids. One of these was Eotyrannus, the dawn tyrant. It wasn't a T. rex yet, far from it. Eotyrannus was smaller and more lightly built, but it gives us a tantalizing glimpse into the early evolution of the lineage that would eventually produce T. In this ecosystem, Neovenator was likely the dominant terrestrial predator, while Eotyrannus occupied a more mid-level predatory role, preying on smaller dinosaurs and other animals. The coexistence of these species shows how predator roles shifted over time. Early on, allosauroids like Neovenator were in charge. Only later, in other places and times, would tyrannosaurs rise to rule. Segment 6, Spinosaurs and the Predator Guild. The Wessex Formation also tells another fascinating story: the coexistence of multiple large predators with very different hunting strategies. For many years, isolated teeth from the Isle of Wight suggested the presence of a Spinosaur, possibly the well-known Baryonyx. Its discovery in mainland England had led paleontologists to assume that similar teeth on the Isle of Wight belonged to the same species. But in 2021, new skeletons changed that view. Two partially preserved Spinosaur skeletons were described from the Wessex Formation, not far from where Neovenator was found. These were identified as two entirely new species, Ceratosocops and Riparivenator. Both are known from skull fragments, and Riparivenator also includes part of a tail. This meant that the Wessex Formation wasn't just home to Neovenator and Eotyrannus, but also to at least two Spinosaurs and yet another large unnamed theropod known from fragmentary remains. How could so many large carnivores share the same environment? The answer lies in niche partitioning. Spinosaurs like Ceratosocops and Riparivenator had long, crocodile-like snouts and conical teeth, features ideal for grabbing slippery prey such as fish and other aquatic animals. Neovenator, on the other hand, had serrated, blade-like teeth, well suited to slicing flesh from large terrestrial herbivores. By focusing on different prey. Spinosaurs more on aquatic animals, Neovenator more on land-based herbivores. These predators reduced direct competition. They could coexist without constantly fighting over the exact same resources. That's not to say there was never conflict. Estimates suggest that the Spinosaurs may have been as long, or even longer, than the best-known Neovenator skeleton. But there is unconfirmed evidence that some Neovenator individuals could grow even larger. A particularly big Neovenator might have posed a serious threat to Spinosaurs, especially in times when prey was scarce. In those moments, during droughts, food shortages, or seasonal stress, Neovenator could well have been a dinosaur that even Spinosaurs had reason to fear. Segment 7, a sensitive killer. Neovenator wasn't just big and powerful. It was also surprisingly sensitive, at least in the face. When scientists examined the bones of its upper jaw, the maxilla and premaxilla, they noticed a remarkable texture. The surfaces of these bones were studded with tiny pits and grooves. To understand what this meant, paleontologists used CT scanning to peer inside the bones. What they found was a complex network of canals branching through the interior, connecting many of those external openings. Systems like this had previously been associated with aquatic or semi-aquatic predators, such as plesiosaurs and spinosaurs. In those animals, the canals were thought to house nerves and blood vessels, analogous to the pressure sensors in modern crocodilians. But Neovenator shows a similar system, despite being a more typical terrestrial theropod. This suggests that complex neurovascular systems in the snout may not have been exclusively about detecting underwater prey. So what were they for? Several ideas have been proposed. Social interactions. The sensitive snout could help Neovenator engage in behaviors like facial rubbing or controlled biting during contests with other members of its species, without causing catastrophic damage. Reproduction and nesting. The snout might have helped detect temperature changes or subtle environmental cues, allowing Neovenator to choose good nesting sites or manage their eggs, similar to some modern crocodiles and birds. Feeding precision. Perhaps the most intriguing idea is that a sensitive snout allowed Neovenator to distinguish between flesh and bone while feeding, letting it carefully strip meat without biting too deeply into the skeleton tooth, where patterns support this last idea. Neovenator's teeth show were similar to that seen in modern carnivores that avoid biting bone, such as cheetahs. This contrasts with the heavily worn, often splintered teeth of bone-crunching predators like Tyrannosaurs. Despite its terrifying appearance, Neovenator may have been a delicate feeder, using its sensitive snout and cutting teeth to slice flesh with surprising precision. Segment 8, evidence of the hunt. We also have tantalizing clues about what Neovenator may have eaten at the same site where Neovenator remains were found. Paleontologists also uncovered the bones of an iguanodontian dinosaur, later named Bristonius. For a long time, these bones were simply labeled as generic iguanodon. Only later were they re-examined and recognized as a distinct species. One Bristonius vertebra shows a particularly striking feature: a set of 3 deep gouges, parallel to each other, carved into the bone. These grooves match what we'd expect from large theropod tooth marks, teeth that pierce through the flesh and raked across the spine. We can't say with absolute certainty that Neovenator made those bite marks. They could have come from a theropod or even a crocodile. But the close association of the Bristonius and Neovenator skeletons at the site makes it tempting to imagine this scene as evidence of a large predator attacking, or perhaps scavenging, a plant-eating dinosaur. Even if Neovenator generally avoided bone contact, as the toothwear suggests, that doesn't mean it never bit bone at all. In a violent struggle or when feeding quickly, accidental impacts with the skeleton would have been hard to avoid. Those gouges might represent one such moment, a snapshot of a brutal encounter frozen in stone. Segment 9, a life written in scars. Neovenator's own bones tell us that life as a top predator was anything but easy. Detailed studies of the skeleton reveal numerous injuries and pathologies. Bony overgrowths on ribs and vertebrae, evidence of healed fractures, signs of infection, particularly in the toe bones, irregularities in the limb bones that suggest repeated stress or trauma. These features echo the famous Big Allosaurus specimen from North America, which also shows a life history written in injuries and healing. For Neovenator, such damage could have come from many sources: violent struggles with large, desperate prey, falls or accidents in rough terrain, fights with other theropods over territory, mates, or carcasses. What's clear is that Neovenator did not glide effortlessly through life as an untouchable superpredator. It was an animal constantly interacting, often violently, with its environment and with other organisms. And yet, many of these injuries healed. That means this dinosaur survived long enough after each trauma for bone to regrow and remodel. Neovenator was not just deadly, it was also tough. Segment 10, the Isle of Wight. Dinosaur Island. Neovenator's story is just one chapter in the geological and paleontological epic exposed on the Isle of Wight. A major fault runs down the middle of the island. Over millions of years, this tectonic activity has pushed up the southern side, exposing rocks that span from around 130 million to about 80 million years old, largely Cretaceous strata, including the Wessex Formation on the northern side. Much younger rocks are exposed, dating from roughly 50 to 30 million years ago, with even more recent deposits on top. By walking along different stretches of coastline, you can effectively walk through around 100 million years of geological history. Many of these rocks are rich in fossils. Some contain dinosaurs like Neovenator, Tyrannosaurus, Bristonius, and the Spinosaurs. Others preserve turtles, alligators, and prehistoric mammals. Ice Age deposits yield remains of mammoths, bison, and hippos that lived only tens of thousands of years ago. Because the rocks are so well exposed and continuously eroding, the Isle of Wight has become famous as the UK's Dinosaur Island. Today, guided fossil walks, like those run by local experts, help visitors safely explore the beaches, understand the geology, and spot fossils that might otherwise go unnoticed. Field guides and local museums tie everything together, allowing anyone, not just paleontologists, to appreciate this extraordinary natural archive. Legacy of the new hunter. Neovenator is more than just a big carnivorous dinosaur with a dramatic name. Its fossils have revealed that early Cretaceous southern England was home to powerful allosaurian predators, that the Wessex Formation hosted a surprisingly complex predator guild, with Spinosaurs, Tyrannosauroids, and other large theropods sharing the landscape, that some theropods, even fierce ones like Neovenator, may have had highly sensitive faces and careful feeding strategies, and that life, as a top predator, was often brutal, leaving scars etched into the bones that we can still read today. Standing on the modern beaches of the Isle of Wight, it can be hard to imagine animals like Neovenator stalking through forests and floodplains where seaside towns now stand. Yet every year, storms and tides continue to reveal new fossils from the cliffs, offering fresh insights into this long-vanished world. Neovenator embodies the power of those fossils to surprise us. It shows that even in places we think we know well, like the quiet countryside of southern England, the deep past can still hold creatures so fearsome that even other dinosaurs might have dreaded crossing their path. And thanks to the ongoing work of paleontologists, local experts, and fossil hunters, we're still uncovering new pieces of this story. One bone, one rock layer, one discovery at a time. In our modern world, England isn't exactly famous for terrifying wildlife. These days, the most dangerous large animal you're likely to meet in the countryside is a cow. Wolves, bears, and other big predators are long gone from these lands.